Hello everyone, Bharat here. In this video, we are going to look through how MapReduce program works in a Hadoop cluster using the Horton sandbox. So to explain more further about the MapReduce program, we have made use of this community tutorial which is available in GitHub. Before we start how MapReduce works, let us look through the prerequisites what is required to run this program. So we need a virtual machine. In this case, I'm using a Horton sandbox as mentioned in the website. Along with that, we would be needing a version of 6 or above of JDK and JRE. Along with that, it needs to be supported with any IDE. For this example, I have made use of Eclipse. And further, if you see down, we can see that we need a set of jar files which is required to run this program on Eclipse. So to take care of the MapReduce program, we have the set of links where we can download these jar files which is required to run the MapReduce program. So to for this video, I have made use of an example of the general elections in Ethiopia. So this is an imaginary country which is having a set of five president contestants who are trying to participate in an election, and we are going to write a program to read a set of data sets and find out who has received the maximum number of votes. So this is the layer of the problem statement here, and if you further go down, this website clearly explains what is the code that is required to run this program in Eclipse and what are the set of prereqs that is required as well. So let us jump into directly Eclipse and see the code and its execution. So I have copy pasted the code from the website and I have made a Java project on Eclipse along with the three Java files. Here you can see through the code, it's a typical three-phase mapper reducer Java program, which is having a file for the mapper, a file for the reducer, and a file for application, which would be as a communicator between the mapper and the reducer. So if you skim through the code, it is pretty simple and it has a basic set of commands which helps you to understand the word count for any set of Java program. Along with that, I would also like to explain that a set of referenced library files have been added, which I have previously mentioned in this link here, which we need to download these jar files to run the MapReduce. And I have added all those files in our class path, and the class path can be given by right-clicking and going to build path and configure build path. Here we can add the list of jar files which we need. As I have already added to that, the code is all set to be run. So this is the Hue editor which is being run on a virtual machine. I have built it with the help of Cloudera Sandbox which has been run via Oracle VirtualBox. And here we can see that for our use case we have made use of two datasets called as booth1 and booth2.txt. If we go through the file, we can see the dataset just contains the list of names of the candidates who have got their vote in the chronological order. And here you can see that if you see Jaja in the first name, it means Jaja has got the first vote and the next has gone to Gigi and so on. So here basically we need to write a MapReduce program which helps us to count the number of words as in the word count program in Java. So let us start with by running the code in the Hue editor. So here we have placed the data sets in this path and the same path has been configured in our Eclipse code as well. The jar has been exported and has been again read here in the Hue editor. Now we can run the query by going to the command prompt and running the yarn code, which helps us to transfer the jar file and merge it with the Hadoop cluster. Now let us run the code. As I have already attempted it 6 times, I'm going to change the file output file name to 7. And here we can see that the MapReduce program has run successfully when we have been given the number of processes and the number of splits. And finally, here you can see the URL which gives us the location of the output. By just copying the URL and pasting it in the web browser, we can see the output. So here we can see that the MapReduce has been run successfully for the Utopia word count jar, and it has total taken completely of 27 seconds here. Further, we can also look into the output by browsing through the folder of user slash Cloudera, and we have given the name, and here we can see that this file part hyphen r hyphen five zeros is the file which is required to read the output. By just downloading this file into our local, we can see the output as in the number of votes which has been casted or the vote count. So here we can see the output as Jaja has got 6, Gigi has got 6, and so on. So this is the way the MapReduce program helps us to get the word count for a given data set. Thank you for watching.